This is the 27th episode of our Chinmaya Algebra series, and for this video, we are given that a plus b plus ab equals 3, b plus c equals 8, c plus a plus ca is equal to 15, and we're looking for the value of 12abc. This problem is quite different than the previous videos in that it does not involve quadratic functions. There's a very nice trick here, and that trick would involve this relationship. Uh, Consider the product of m plus 1 and n plus 1. When we expand this, we get mn plus m plus n plus 1. This is quite similar to what we have here, except that it's missing the one term here. So if we add 1 to both sides, we get this left side being equal to a plus 1 times b plus 1, and the right side is equal to 4. We do the same with the second and third equation to get b plus 1 times c plus 1 is equal to 9, and then c plus 1 times a plus 1 is equal to 16. Now we can multiply all these equations to get the quantity of a plus 1, b plus 1, and c plus 1 squared. They are squared because each term here appears twice. We have a plus 1, a plus 1, b plus 1, b plus 1, c plus 1, and c plus 1. So the left side of this product would be the square of the product of a plus 1, b plus 1, and c plus 1. Meanwhile, the right side here is equal to 2 squared, 3 squared, and 4 squared. Therefore, their product should be equal to a square as well. So that's 2 times 3 times 4 squared. Of course, this can be simplified to just 24. Therefore, the product here, if we take the square root, we get a plus 1, b plus 1, and c plus 1 should give us plus minus 24. Note that we will consider two signs here because both positive and negative would give a square that is positive 24 squared. So this is an important relationship because if you notice, for each of the equations here, they're only missing one factor. That is, in the case of the first one, that's c plus 1. So if we rewrite this one in terms of this, it's actually a plus 1 times b plus 1 equal to positive negative 24 over c plus 1. Okay, so this first equation here should be equal to plus minus 24 over c plus 1 is equal to 4. In other words, c plus 1 is equal to plus minus 24 over 4, which is equal to plus minus 6. So c plus 1 is equal to plus minus 6. So I'll just put the result here. C plus 1 is equal to plus minus 6. We can do the same thing here to get a plus 1 is equal to plus minus 24 over 9, which when simplified is positive negative 8 over 3. Lastly, the third one should give b plus 1 is equal to plus minus 24 over 16, or simply positive negative 3 halves. Therefore, we have actually two sets of solution here. The case when we are considering the positive case and the case when they are negative. So let's consider first the case when it's positive. So c plus 1 is equal to 6, which means c equals 5. A plus 1 is equal to 8 over 3, which means that a is equal to 5 over 3. B plus 1 is equal to 3 halves, and so b must be equal to 3 halves minus 1, which is 1 half. The product of those three is ABC is equal to a thirds times 5, erase. That's 5 times, uh, let's do in order. A is 5 thirds, B is 1 half, C is 5, which when simplified is 25 over 6. So that's one possible value of ABC. If we're looking for 12ABC, which is what we're looking for here, that should give us 12 times 5 over 6, cancel out the common factor 6, that should give us, this is 25, that should give us 50. Therefore, one of the answers here is 50. Now let's go to the negative side. We have c plus 1 equals negative 6. So c is equal to negative 6 minus 1, or c equals negative 7. Do the same for a. A plus 1 is equal to negative 8 over 3. So a equals negative 11 over 3. B plus 1 equals negative 3 halves, which means that b is equal to negative 5 halves. Therefore, ABC in this case should be negative 11 over 3 times negative 5 halves times negative 7, which is equal to 11 times 5 times 7, that's 385, but this is negative over 6. Therefore, ABC in this case is negative 385 over 6. Multiply that by 12, we get 12 times negative 385 over 6, or negative 770. Therefore, the answers we're looking for are actually 50 and negative 770. And that's our final answer. So again, the most important trick here is to rewrite each equation in terms of this product here. Everything else should follow. I hope you learned something from this video. Thank you for watching, and please subscribe for more content.